Alright, now we are getting into some problem solving with standard deviation, and one typical type of problems that you would see in GMAT statistics is when you are asked, is the standard deviation of a series greater than 0? Let's look at some of the concepts and fundamentals involved here before we start practice questions. So the first thing that you should know is that the standard deviation is always greater than or equal to 0. So when a question is asking you, is the standard deviation greater than 0? What they are really asking you is to eliminate the choice that standard deviation can be equal to 0. It is a very common type of data sufficiency questions, and it usually has different information given about the series, sometimes the mean, sometimes the median, sometimes some numbers or the others. However, the question and the goal is the same. You have to eliminate the standard deviation equal to 0. Since this is a yes or no type of questions, you need a unique yes or no answer to the question based on the information given. So if there is any ambiguity or vagueness around, sometimes it could be greater than 0, but there are possibilities it could be equal to 0, then the data will be considered insufficient. And while this looks easy and the concept involved is easy, it can get really tricky, resulting in errors, even though the overall difficulty level of the problem is less. What does that mean for you? What it means is that if you get a lower difficulty level question wrong because it had a trick, you drop down in the computer adaptive algorithm to a much lower difficulty question, resulting in a big impact to your score. Alright, so we just talked about how to approach the standard deviation greater than 0 problem. Here is a practice problem. You can absolutely pause here to solve the problem on your own if you haven't tried it already. However, I am going to get started with talking about some of the concepts involved here. Okay. So as I said before, the concept here is very easy. The concept here says that standard deviation is always greater than or equal to 0. It is equal to 0 when all the numbers are equal, and it is greater than 0 when even a single number is different than all the other numbers, right? The approach to solve this is to figure out if there is at least one number that is not equal to the rest of the series. If you are able to find that, then you know that the standard deviation has to be greater than 0. Okay, so let's solve this question now. We are given that there are 18 numbers in the series. These are numbers, so we are not given whether the numbers are integers or non-integers, so they could be decimals or fractions or anything. And we are asked if the standard deviation is greater than 0. Since the sum of the numbers is 75, each number could be 75 divided by 18. So basically one possibility is all 18 numbers are 4.17, which results in the average to be 75 divided by 18, and hence the standard deviation equal to 0. That answers the question as no, standard deviation is 0, it is not greater than 0. However, since the question doesn't really give us that all numbers have to be equal, there is a good chance that some numbers are more than 4.17 and other numbers are less than 4.17, resulting in standard deviation greater than 0. So in statement 1, with the information we are given, all we can say is sometimes the answer is no to the asked question, sometimes the answer is yes to the asked question. Hence there is no unique yes or no. Hence, statement 1 is insufficient. Okay, in statement 2, we are given that the range of numbers is 10. What does a range mean? A range of numbers is highest number minus the lowest number. So we know that the two number in the series, the highest one and the lowest one, are actually two different numbers. If they were all the same numbers, then the range would be 0 as well. So we know at this point that at least two numbers in the series are different from each other. Since they are different from each other, the standard deviation can never be 0. Hence, the standard deviation has to be greater than 0. Hence, statement number 2 is sufficient to answer the question, and the answer to this question is B. Statement 2 is sufficient to answer the question, but not statement 1. I hope you found this helpful. Please take your time to reason it out yourself again so that you get more familiar with it, and we have another practice question coming up to actually practice these concepts. So here is a quick review. The concept is that by definition, standard deviation is greater than or equal to 0. It is equal to 0 only when all the numbers are equal. If any two numbers are different, then it is greater than 0. And for problems like that, we are going to use that as our technique to solve the problems. If we are able to determine that at least two numbers are different in the series, then we know that the standard deviation has to be greater than 0. So we have to either determine that all the numbers are equal or determine that at least two of them are different, and then we will have a unique yes or no answer to the question. Okay, so here is another question where we are going to practice the concept, is standard deviation greater than 0, using the fundamental that standard deviation is always greater than or equal to 0. You can pause this video here to attempt it yourself if you have not done that already. However, I am going to get into the concept, technique, and the solution to this problem. As we know that the concept is standard deviation is always greater than or equal to 0. It is 0 only when all numbers are equal, and it is greater than 0 rest of the times. The technique to solve questions like this is to determine if all numbers are equal or if any two numbers are different. So if you are able to figure out if the numbers are different, you don't need to really know what numbers are and what is their actual values. As long as you know that the numbers are different, you know that the standard deviation has to be greater than 0, answering the question uniquely. Okay, so let's get into the solution of this problem. So let's just make sure that we have our information correct, because information is very important here. So here we are given 10 integers, not any numbers, integers. So they can't be decimals, they can't be fractions, and this is a key piece of information that you might overlook in an exam and you should practice not to. Okay, so we are given 10 integers and we are asked if the standard deviation is greater than 0 as expected. In the statement number 1, we are given that the mean of the sequence is greater than the median of the sequence. If all numbers are equal, right, 5 5 5 5 5, the mean and the median will also be equal, whether there is even number of elements or odd number of elements, and you can quickly check that. Right here I am given that the mean is different than the median. The only way that is possible is if there are at least two numbers that are different, which means all numbers are not equal, which means that standard deviation has to be greater than 0, because equality is not possible. Standard deviation cannot be equal to 0 because all values are not equal to each other, and hence this statement is sufficient to answer the question. So we know that 1 is sufficient to answer the question. Let's look at statement number 2. The statement number 2 just gives us that the sum of these numbers is 95, right? And as we did in the previous question, if the sum of the numbers is 95, I could divide them by 10 and get the average as 9.5, which means that each number could be equal to 9.5. But here is the critical piece of information. These are not any numbers. These are integers. Integers cannot be decimals. The only way in this sequence these numbers can be equal is when all of them are 9.5 each. But these are integers, so that is not a possibility anymore. So this possibility doesn't exist, which means some are more than 9, other are less than 9.5, resulting in average of 9.5. Hence we know that in the series there would be numbers which are not all equal to each other, which also gives us standard deviation greater than 0, because the possibility of standard deviation being 0 is eliminated since all the numbers are not equal to each other. So statement number 2 is also sufficient to answer the question, which means the answer to this question is D. The concept hasn't changed, the technique hasn't changed. What changed here is how the information is presented to us and what is given to us about the numbers themselves, which is that the numbers are integers. I hope this concept is getting clearer in your mind. Please feel free to go back and practice this concept again for these two questions, just so that it reinforces in your mind. Let's move on to the next standard deviation concept.